So I'm going to open it up to some questions now to the audience.
This is for Professor Li. Most of the buildings we see have very little permanent dead load moment on the shear walls. Generally, the moment comes from the wind or the earthquake only. And we talked about buildings being repairable after a moderate earthquake. What if we had a building, I would like your comment on a situation where we have a building with a very large permanent dead load, where as the earthquake cycles through, the building constantly shifts only in one direction. The yielding is only in one direction. Would you recommend that in a case like that, that we keep the resisting system in the elastic range for the moderate earthquake? Or could you give some idea of how much permanent dead load moment ratio to seismic ratio you would be happy with?
Thank you. It's a very good question. Yes, we require the structure repairable. I think it is because the cost, the economy. Yes. So if the building has very large residual drift in one side, probably it is hard to repair. So, firstly, probably we should limit the residue drift for easily repair the building. So this is the requirement to limit the story drift. The other proposal, probably you just mentioned that if you can keep the structure in more static state, so the deflection can be recovered automatically. Actually, there are some proposals for this technique to keep the structure in more elastic, and a certain level of earthquake. This is because of recovery for recovery of buildings. Yes. Yes. Yeah, you are right. Yes. And your second question is about what is the proper ratio of a dead load and the lateral load. It is very hard to answer what is the minimum requirement for this ratio. Yes. But definitely the ratio is lower. Probably it is better. It is easier for building to recover to its original position. Yeah.
Thank you. Other questions? Please.
This is for Mr. Gio. That structural steel embedment in the shear wall. You have said two-phase reinforcement, and inside you have put the steel plate. I just wanted to know that is there is in a lateral tie you have shown it the drawing to be provided from one phase to another phase. So are you welded that, or you put the hole and connected the two surfaces? This is one thing. And second thing is to have a monolithic construction, the composite. Are you provided any shear stud, or it is only by way of embedment?
Thank you for your question. The first, the connection between the steel plate and steel profiles. We have actually we have tried some different way to connect them, and finally we find the welded one is the best has the best performance. But we have tried some not weld all along the height, but you can weld a part of them, and but you have to weld the part at the corner between the profiles and the beam and the plate. This is the most important part of the shear wall. The first one, and the second is that we have the shear stud, or you can actually sometimes we can use some rebars with holes to provide this. Thank you very much.
Thank you. Other questions?
我想请教就是肖总两。
I want to ask two questions to Mr. Xiao. The first question is about specimen. The specimen is some profile material. How do you do the simulation? The second question is addressed to Mr. Xiao. For shear wall, and when you design the steel plates, what kind of key characteristics do you have?
The first question is about its scale model, and how do we have a shear stud in the test, and how to simulate it. Actually, we use small ones, not the real shear stud, to present it. But the design method for the shear stud is not. I think it's not clear how to design the amount and for the shear stud. So we simulate like you have to transfer the proportion of the steel plate, the shear stand with the steel plate to the minimum value of the steel plate and the concrete, and you have to design this with the minimum value. 一翻译就忘了，第二个是什么问题来？
是我想请教一下肖总，就是这个
About the shear studs. So, when you design the shear studs, what are the key considerations?
So the question I answered him with Chinese. 就是说钢板的这个剪力。
The shear transfer, the design method is not so clear, but basically, you use steel proportion, and the concrete you take the smaller value. That is a conservative method. There are some super tall buildings in Shanghai and Wuhan, and they have different designs for shear walls. Some is very precise, some is follows the diagonal. So, what are the different considerations? Which one is more appropriate? We need to do further studies. For shear wall and the composite column, we don't have a very clear answer.
I have a question to Mr. Jose. The BRBs you are using are mainly viscoelastic dampers, no? And what is the damping level you are getting with those?
We have not checked the damping level specifically, but there might be some additional damping from the BRBs, yielding of the BRB hysteretic behavior. But we haven't compared with the original system without BRB and the system with the BRB. It is sure there might be increase in damping. But in our modeling, we use 2% to 3% of damping in our model. Other additional damping due to the yielding of the shear walls and yielding of the coupling beams, yielding of the BRBs, it will consider in the analysis from the hysteretic behavior. So, but we haven't compared these damping from the nonlinear time history analysis. If we conduct the pushover analysis, we can compare from the pushover curve for these additional dampings.
But I mean, how are you getting the 2 or 3%?
2 or 3% is the common practice for the concrete buildings. First, we use 2% in the mode 1, and in the mode 4, we use 3% for relay damping. There's in the latest ATC 72.1 document, there are some formulas for the damping estimation of the buildings. We can check from these formulas.
In the back over here.
Great. Hi, my name's David Farnsworth from Arup in New York. First off, I'd like to thank all of the speakers for their presentations today. I've very much enjoyed them. This question is for Professor Li. Thank you for the presentation comparing all of the performance-based seismic design requirements around the world. It's something that I work on projects all over the place, and it's nice to see a comparison side by side of the different requirements in each. One of the things that I noticed is many of the Chinese criteria are quite more stringent than other similar criteria in other parts of the world. You know, the drift criterias are more strict than drift criterias in the U.S. and most of the other places that you put up. There's also differences in terms of the interpretation of the minimum base shears, whereas in most parts of the world, the codes require you to scale up the design forces for the buildings to, be designed to withstand the increased, forces in the shears, or the increased forces and moments associated with the minimum base shear. Whereas, in my experience, most of the expert panels and the Chinese code authorities expect you to stiffen the building so that it attracts the minimum base shear rather than scaling up the forces after you've run your analyses. Do you see the Chinese code coming more towards coming more in alignment with the rest of the world with regards to the seismic design, or do you see it continuing its own path?
Yes, there are some differences between the Chinese code and with other codes of the other country. I think there was something is the same. For example, the definition of a frequent earthquake, moderate earthquake, and severe earthquake, and the capacity requirement and service deformation requirement. I think that these are the same. The fundamental principle is the same, but something is different. You just mentioned the deformation requirement, especially elastic deformation requirement, probably is more how to say,
strict.
Strict, yes, more strict than the other codes of other country. Yes, I think when, especially for tall buildings, super tall buildings, so more and more the structural engineer find this is really a problem. And I think probably in future, probably in near future, there is some change. They will change. The code will change on on the specification. Yeah. But I do not know when it will change. But it will change.
Thank you.
All right.
May I have some words because most of the structural code are compiled in our academy, so I have to defend some. Yeah, I think it's different from what you did in China is mostly super high-rise building and very, very tall or very, very complicated. So some regulations or it's not totally in the code. It's some regulations just for we call the overlimit. So, such as in our code, we have a base shear limitation, minimum base shear. They don't ask you to make your structure more stiff to get together that stiff. But for the buildings lower than the limit. But if you have buildings higher than such as 150 meters or even more high, such as 600 meters, you have to be approved by an expert panel, and they will give you some more restricted advices. So it's not in the code. It's a special requirement. But we are still doing some things, especially for the base shear, because I know in the recent years, like the height of the structure comes to 600, or also the most difficult thing is to get to comply with the minimum base shear. So we have discussed some alternative way to solve this, but it's not get or everyone agreed. So it may take times, but I think will not be very long. Thank you.